Due to the current coronavirus and the stay-at-home order, I am the only adult in my house. There is no audience except for two tiny people who are hiding in my bedroom right now. In most states in California, diesel trucks must pass an emissions test to be road legal. With the help of the EPA creating standards for the emissions allowed to be released from a vehicle, reducing our carbon footprint. Diesel engines contribute to polluting our atmosphere, and these emissions standards in place so we reduce some of it. Diesel engines are dirty, and with emission standards from the EPA, they produce less NOx. While learning about emission systems in class, I noticed a debate if the new emission system is reducing NOx. I used my light-duty diesel textbook and my online sources. First, I will describe the exhaust gas recirculation and how it reduces NOx. Second, I will explain the diesel particulate filter and how it burns soot. Finally, I will discuss the diesel exhaust fluid and the selective catalytic reduction, how they further reduce NOx. Diesel engines are dirty, and with the emission standards from the EPA, they produce less NOx. The exhaust gas recirculation system takes exhaust gas back through the engine to be reused and reduce NOx. Is the EGR effective being used or deleted? There are potential legal complications if you make this modification on a vehicle you drive down the street. If you use it for off-road driving, then the environment becomes a concern for your engine too. This is written by Miller. While the EGR decreases the pollutants entering the atmosphere by a minimal amount, they decrease the engine's ability to breathe and can decrease the fuel economy as well, said by Busby. The EGR, exhaust gas recirculation system, reducing NOx. An EGR system routes a portion of the exhaust gases back into the engine intake tract. Prior to being rerouted and mixed in with clean oxygen, the exhaust gases are cooled in an EGR cooler. This is accomplished using the engine coolant and metered through an EGR valve, as wrote by Mike McLaughlin. Since 2004, almost all highway diesels have had some sort of EGR, usually cooled EGR, CEGR, from Bennett. The EGR system reduces NOx, sending exhaust gases back through it. After going through this, the exhaust gases go to the DPF to burn soot into ash, reducing the hydrocarbons but raising the NOx. The diesel particulate filter catches the hydrocarbons, or HC particles, and then raises the NOx. The DPF is a crucial part of the emissions process to reduce HC. Active regeneration uses fuel sourced from the fuel subsystem and delivered at specified charging pressure, from Bennett. Diesel particulate filter and the regen cycle to burn soot. As with any filter, they should be emptied regularly to maintain performance. For DPF, this process is called regeneration. The collective soot is burnt off at high temperatures to leave only a tiny ash residue, as said by Sanders. The regeneration cycle relies on extreme heat to burn off the trapped particles within the diesel particulate filter. There are three types of regeneration: active, passive, and manual, from McLaughlin. The DPF uses regeneration to reduce hydrocarbons, raises NOx. So now the selective catalytic reduction. Wesley! The SCR uses diesel exhaust fluid to reduce NOx and releases nitrogen and water out of the tailpipe. The final step of the emissions system is the DEF and selective catalytic reduction. The DEF is a urea that is injected into the SCR at the end of the regeneration. From the particulate filter, the exhaust gas travels past the nozzle, which sprays DEF into the stream of gases. DEF is made from deionized water and a very pure form of urea, stated by Hyatt. The government mandates have given manufacturers little choice but to use DEF to control those nitrogen oxides to meet emission standards required to keep our beloved oil burners on the road. Written by Warner. The SCR is required by the EPA as of 2007 to reduce greenhouse gases. The hot exhaust gas and DEF then enter the catalytic converter where the urea from the DEF and exhaust gas react with a variety of metallic components to convert nitrogen dioxide and monoxide into nitrogen and water, or by HIAT. SCR technology is designed to permit nitrogen oxide NOx reduction reactions to take place in an oxidizing atmosphere. It's called selective because it reduces levels of NOx using ammonia as a reductant within a catalytic system. Stated by Steve Hansen. First, I described the EGR systems and how it reduces NOx. Next, I explained the DPF and how it burns soot. Finally, I discussed the DEF and SCR and how they further reduce NOx. Diesel engines are dirty, and with emission standards from the EPA, they are producing less NOx. Diesel engines are dirty and known to produce pollutants. The EPA has put out regulations to cut down on these pollutants, and manufacturers have created the emission systems we have today. You could be fined for moving the EGR, DPF, DEF, and SCR components. In most states and California, diesel trucks must pass emission tests to be road legal.